Okay, today we'll be talking about exceptions and assertions, mostly exceptions. So, the whole point of exceptions, and to a lesser extent assertions, is to make sure that your code has a way to gracefully fail when it runs into an error. So, for example, let's set up something in here. I'll give you an example of some horrible thing that can go wrong. So we'll make a class, we'll call it fun with exceptions. We'll give it a main class. And we will give it a scanner. And in our class, we will have one method. We will say, system that out, print line. Please enter a number between 0 and 10. Okay? And then we'll do int x equals new scanner dot next int. Okay, and then our program. Oh, system.in. Yeah. And then we'll print out you entered the number plus x. Okay, so it's a very simple program. Just got a prompt for some input, and it's going to expect us to enter an int, then we're going to enter something, right? So what happens when we run this? Well, please enter a number between 0 and 10. And I say, no way, man. I get some kind of exception, right? Because it can't process that into a number. This next int, if I hover over it, it's supposed to return an int. Well, it has no way to translate this text, this non-numeric text, into an integer. Same thing, right? Other things can go wrong. Enter a number between 0 and 10. Well, for example, if I type in the number 3 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3, too big to be stored as an int, right? It wants to convert it to a long. So same problem. Let me do that to print line because that's annoying. Okay, likewise, what else? Enter number between 0 and 10, 5.5. Well, guess what? It can't convert that double to an integer either. So all sorts of things can go wrong. Now, what you might say is, well, I'm going to put in some mechanism on the web page where the user can't enter in data in any form so it doesn't actually turn into an integer. But that's kind of a hassle. You don't always want to do that. Instead, you might do this. You might say, well, recognizing that this code might cause a failure, right, cause the program to crash, I will put in some code to allow it to fail gracefully, right? And with hope of recovery. So what I can do, the basic syntax for that, I have what are called try-catch sequences. So in the try part, that's going to contain the code you know might fail. Good, the long guys are hopefully done. Or not. Okay, the second part, so we do that, we encase this code in a try block. Oop. And in particular, right, we know this is the line that might fail, this int x, but since this is all part of a logical unit, we're going to bundle it together. And then the catch, we're going to catch some types of exceptions. We'll say, catch part will be what? The response to the failure. Okay, so we can say something like this. Improper input format. Okay, and then the program doesn't give us all that horrible stuff about why it failed. So we'll just say, please enter a number between 0 and 10, and we can do R. Okay, and it just says, oh, improper input format. And if we wanted, we could, of course, embed this in some sort of loop that kept on going until we entered the proper format type. Okay, so that's the basic thing with try-catch. We have, in our try block, we have some code that we know might cause the program to crash. And in the catch block, we have whatever code we use to try to recover from that. All right. Any questions on that to start with? Does that all make sense? I hope it does. All right, fine.
So would this be used as like a supplement for like if and if else?
Potentially. I mean,
okay.
It depends, right? So this,
Yeah, 'cause I know that
this can cover things.
Accept different parameters, and this
Right,
one
but the
wouldn't.
problem with ifs and elses, right, is that the code, the values have to be valid in some sense to be tested at all, right? The program has to run. Now, you could, something simple like this, sure, you could do that. You could say, well, you know, I'm going to get it as a string and I'm going to try to convert it to one of these other formats, but it's often really complicated to do that, right? But yeah, something like this, you could potentially cover that with ifs and elses. But there are other exceptions for things like hardware failures, right? For example, if you exceed the available memory capacity on your machine, or if there's, you know, you try to access the hard drive, but for some reason the hard drive is failing, that's the stuff that it's not going to be very easy to put into some kind of if-else structure. Okay, so exceptions, yeah, they have a, you know, a branching component to them for sure, but it's a much broader, all-encompassing thing than if-else statements.
Thank you.
Sure. All right, that's a good question. All right, anything else? Now you'll see some cases in the slides where they do, in fact, exactly make custom exceptions to cover those kind of cases that they could cover with ifs and elses. But the exception is a way to basically standardize the process. All right. So what we're going to do, eventually, first thing, which we've already done, I guess, we've introduced the concept of exception handling. Assertions we just tack on at the end because it's kind of the same, but with a slightly different syntax and purpose. We'll write some methods that propagate exceptions. So this one that we see here, if the exception happens, if the problem happens, it's handling it locally in that same method. Propagating means I'm not going to handle it here. I'm going to handle it in the method, one of the methods that called this one. Programmer-defined exception classes, those are our custom ones. We'll eventually get to them. And we'll talk about the difference between checked and unchecked exceptions. Okay, so moving on. An exception is some kind of error condition that happens while a program is running normally. The technical term for what happens when this exception occurs, we say it gets thrown. So the program is running along and it throws an exception. So we know that something went off the rails. And when that happens in most cases, right, the normal flow sequence gets interrupted. Just like we saw the very first bit of code I did. If I entered in the wrong input type, the normal sequence of flow got interrupted, right? The program crashed. So when something happens, some kind of exception happens, there's always going to be some kind of exception handling routine that gets executed. And we say that that thrown exception gets caught somewhere. Now, I'm going to introduce a concept called the stack. And understanding the stack is going to help you a lot to understand how exceptions get processed in Java. Okay. So let's look at this program that I have already written. Okay, we have our main class, our main method rather, and the main method calls nextInt, right? Scanner.nextInt. And those at this point are the two that we're concerned with. We could also add on from the JVM itself. Okay, so the basic sequence, what's going on here? JVM initiates program, right? We can say it initiates the main application thread, just like we talked about threads last week, and calls Main method. So that's the first thing that happens, right? In our main method, as we've written, eventually calls scanner.nextInt. Okay? And scanner.nextInt has its own set of method calls that aren't really visible to us because they're part of the, core Java language classes. Okay, but they're in there. This nextInt method, you can bet that deep in the guts of Java, it's calling its own methods and doing its own things. Now, this whole structure basically gets converted to a stack of method calls. So down at the bottom, the very first one that happens is this JVM. Okay, that's method call number 1. When the JVM calls the main method, guess what? It adds this new method onto the stack. So this is the way it happens. When the main method is done, it returns control to the JVM's execution flow, right? Just same it is with any method. When the method finishes, it bounces back to whatever method called that method. So the Java virtual machine calls the main method runs and does all its stuff, and at the end, when it's done, it pops back to the JVM and says, okay, you do what you're going to do now. Okay, well, in this case, again, this one calls scanner.nextInt. So I'm just going to call that nextInt here. Okay, and again, we know when nextInt is done, it returns the flow back to main. Okay, we understand this, I hope. If you have questions, by all means say so, but this is what we've been doing for a while. One method calls another. Whenever this method is done, it goes back to the method that called it. Well, here's the thing, right? This is the reason why exception handling is done a certain way in Java. Use some orange. Java wants to handle exceptions in the least disruptive way possible, okay? That means don't crash the entire program down to the JVM. Much better to handle exceptions as locally as possible, right? So if you can, you'd like to handle an exception in this nextInt method within nextInt itself, but Scanner doesn't do that. So Scanner says, well, if you're going to call this nextInt, you have to be prepared for the possibility that the input might have been wrong. So instead, it's much better to have this main method handle the problem, okay? Because otherwise, if the main method doesn't handle it, it crashes back to the JVM, and the JVM doesn't have another way to recall the main method. The program ends. And you can imagine in an enterprise setting, right? In an enterprise setting, letting the whole program crash is very bad. That means everything's going to be down for a while until you can figure out some way to restart things, right? And hopefully avoid that error from happening again. Okay, does this make sense? So this is what the stack is. The stack is the sequence of method calls. Okay, and as you would say in accounting, it is last in, first out, right? So whichever one gets added last is the first one that goes away. So once nextInt is done, it goes away, and we go back to the main method. Okay. Questions on this? This is a core computing concept. Anything? Anybody? How we all doing? Does this make sense? It's good? Yes? No? Maybe? I'm going to take that as a maybe. Okay, moving on. Back to the PowerPoints. So this is basically the same bit of code that I have in my application, right? We have a scanner, we ask for an integer, we enter in a number. If we enter in something different, right, you're going to get this java.lang.input mismatch exception. It's a specific type of exception that says, I was expecting one type, you gave me a different one. And of course, that's what happens when the entire program crashes, right? It prints out this basically what's called a stack trace, the entire list of method calls up to the point where the crash happens. So main called scanner.nextInt, scanner.nextInt did something else there, got processed into scanner.int, got processed into this throw for method. Okay, and then there, boom, what it threw was this input mismatch exception. So the problem happened in scanner, it threw an exception, there wasn't any way to handle it in the stack, and so it crashed all the way down to the Java virtual machine where it displayed the stack trace at the time of the failure. Okay, and the program ends and you have to restart it. Okay, so again, why exceptions make program crash? Java program, as we know, is basically a sequence of nested method calls starting from when the JVM calls the main method. So whatever method an exception happens in, if it's not handled locally, that method will return the execution flow back to whatever method called it. And if no methods handle it, eventually it goes all the way back to the main method, right? It goes back to that very first method called to start the program that's going to be at the bottom of the stack. If the main method doesn't handle it, the execution flow leaves the main method, ends the program, returns control to the Java virtual machine so it can print the error output. Okay, fundamentally that's it. Why exceptions make programs crash. All right, now we're going to put in a very simple and fun one here because everybody likes to see things go off the rails quickly. Oh look, we got more people. Okay, we're going to call this one quick fail. So in this one, we give every quick fail object its own quick fail object. So here in the main method, we're going to say quick fail qf equals new quick fail. Okay, and let's run this and see what happens, and I'll explain why. Boom! We got the Stack Overflow error. Well, what's going on here? Here's what's going on. Every time, okay, so with the initial program launch, we create a quick fail object, right? But, mark that dot number 1, but here's dot number 2. But every quick fail object, when created, gets its own quick fail object, which gets its own quick fail object, which gets its own quick fail object, and so on for about 10,000 method calls deep until the stack can't hold them. Okay, there's only so much memory piled up for the stack to use. If it exceeds that, then it just gives up. It says, you know what? If I have this much stuff piled up in my stack, something's gone seriously wrong, and I just quit. Okay, so that's why it happens. And you get the Stack Overflow error. Okay, so once again, boom, there it is, right? Very quick way to crash a program. Okay, so that's just a demonstration of how the stack works. Okay. Now, to catch an exception, you can do what we did in our initial code. So we have a try block. Whoop, didn't mean to do that. A try block that wants to read the age, right? So we first print out some prompt, whatever it is, please enter a number. Age reads from scanner.nextInt, which expects to get an integer. If it turns out that it's not the correct format and you get this mismatch exception, well, this catch block exists to catch and process any input mismatch exceptions. And so it'll say system.out.println invalid entry, please enter digits only. Okay, so if we want to implement that, right, the simple way to do that in our Fun with Exceptions class, we could do this. We could say something like Boolean is valid equals false, right? So our assumption going in, we don't yet have a valid input value. Okay, so we have this value that we'll use is valid to store the validity. Okay, if we've gotten a valid one of the input. But initially we don't have one. Now, here we can do a do while loop. For example, we could do and then while not is valid. Wow, typing is hard today. Okay, so all this stuff I'm going to bump in. I guess this I'll put here. Okay, so this we got. All right, so we have do this. We're going to try to get this. If we don't have an exception, right, then we'll know is valid equals true. So we can say here prompt, and then the second line, get the input, might throw an input mismatch exception. But if we get here, right, to this line after next int gets called, if we get here, we know the input was okay. Okay, so print that, and say is valid equals true. And then I have for here, this block gets used if the input was improper. Okay, so we can run this, and then as many times as I want to do it, right? It should work. Please enter. So H. No, okay, it asked me to do again. So I try it. Type. There we go. Finally did it. Okay. So very simple stuff. Anyway, so the point of all this allows a simple way, right, without getting real deep into the problems that might arise from formatting or checking values, things like that. It's a very simple way to say, well, did the person at least enter in a numeric value? And then once they've entered a numeric value, right, you could do stuff like that. You could follow up with the if else's, for example, if you like. So we could say if x is greater than or equal to 0 and x is less than or equal to 10, then you could do is valid as true, right? And otherwise you would do else system.out.println, the integer must be between 0 and 10. Okay, so this, again, we have this try catch. If we want to check for specific values, then once we've determined that it's actually an integer, this is an easy way to do that. Okay, so if I did, for example, -1, yeah, it says I entered that, but the integer has to be there. Oh, okay, let's do 2. Great, now I'm done. Okay, questions on this? Does this all make sense? All the stuff we're doing? Nothing? Okay. Well, let's move on a little bit then. All right. Now, the basic way to do it, if you only have one type of exception that's going to happen, right? So here's the flow pattern for that. So we have in our try block a bunch of statements, right? These T statements 1 through N. And the program goes along. Let's assume that T statement number 3 throws the exception. Well, if it does throw the exception, then all of the other statements in the try block get skipped, right? The code jumps ahead to the catch block. Everything in the catch block gets executed. And then after the catch block is done, whatever else happens in the program happens. Now, if there's no exception, then of course you sail smoothly all the way through the try block and you skip over the catch block because there's nothing to catch. Right? That's what we saw here in this program. We had our try block, right? If an exception happens, like say here, we know we don't execute these other statements. Instead, the execution flow goes from here down to the catch block, right? On the other hand, if I enter in a correct value, right, it's going to go straight along through this, and it'll skip the catch block, and then I'll be done. So, okay. Anyway, so that's that. Now, there's a few things you can add in if you want to learn more about why the exception happens. So one of those is you can print the stack trace. So that's just what the Java virtual machine normally does when an exception happens. So if you say print the stack trace, you can see what's going on there. The other is get message. Get message, it'll print out potentially some custom message about the exception. So we can do both of those for E. We can see what gets sent along here. E.get message, and then let's do print stack trace instead. Okay. Oh, we don't print that out. We'll just do it. Okay, now let's run. I'm going to enter in a bad number to start with. Let's do 11. Well, we didn't throw an exception, right? So gloob. Okay, so here we get the same kind of message we do for our stack trace. So first, the exception message is null for this base one, so we don't have one, so it doesn't display anything. That's mostly something you do with custom exception classes. The other, you can see here all the list of methods that it failed, right? So main was at the bottom of the stack, then main called next int, then next int called itself next int, and then that one called scanner.next, and then finally that one called scanner.throw4. That's where the exception happened. Okay. Now, if you have multiple exception types, then you can have multiple separate catch blocks handling all of them. For example, you might have one block for an input mismatch exception, another for an array index exception. So let's say let's do a simple fun with exceptions too. We'll demonstrate that. So we'll give it an array. Okay, so. Okay, so we've got this. Oh, we should import scanner as well. Okay, and what we're going to do here, we're going to have a prompt. So system.out.println, please enter the array size. Okay, and then we'll say f2 equals new int scanner, new scanner, sorry. dot next int. Okay, and of course that could throw a problem. What doesn't it like here? Oh, sorry, yeah. F2 dot array is equal to that. Okay, so we create the array with the new size. All right, so prompt for array size. Create the new array with the input size. And then we can ask for, example, we can ask for an array index. Okay, so we can do another one. For array index. Okay, we do system dot print line. Please enter an index, an array index to update. Okay, and then we'll check that. Okay, so update based on user input. Okay, so please enter the array index. We'll do, oh, we got to get the value first. We'll do that. For new value, so system.out.println, please enter a valid int value. Okay, and then we'll get that, so we'll say value equals, again, this thing, new scanner, system.nextInt, and ask for the array index to update, and we'll say f2.array at index this, right? Equals value. All right, so we got a few things happening here. First, it asks for the size of the array, then it creates that array based on the input size. So that's what this is, right? New scanner system.in.nextInt. We're calling the nextInt method on this new scanner object. Then it asks for a valid int value. We're going to put that into the array. Okay, and again, we'll get that value by reading nextInt. Then it's going to ask for the array index to update, and depending on that, right, it's going to assign that value to it. Now, there's a bunch of different exceptions that could happen here. That's the point of this. Number one, so I'll put that here, multiple exception types are possible here, right? First of all, you might enter a bad value for an array size, like -1. That's not a valid array size. Number two, you could enter something that's not a number. Obviously, that's going to create some problems. If you ask for an int value, right, again, you could enter something that's not an int. For here, please enter an array index to update. Well, you could enter a number that's valid, but one that's not valid for that array. For example, if the array is size 6 and you enter the number 100, well, 100 would be valid, except it's not valid for this array. Okay, so there's multiple different things that can happen. So we're going to take all this and embed it in a try block. And then we're going to catch. All right, we're going to catch all this. We have multiple catches we can do. So we'll do input mismatch exception E. Right, that's going to print one thing. Let's move all this over a bit. Okay. Did I spell something wrong? Oh. Okay, that's strange. We have another one for array index out of bounds exception. Okay, this one, right, is for if I try to call some value that's not valid. What's the other one they have in here? Yeah, array index out of bounds. Well, let's see how this goes. So I'm going to print thing here, system.out.println, improper input format. In here, I'm going to say index out of bounds. Now, of course, I won't ever get anything about the value itself, right? Because if I get to this point, where it asks for the array index to update and based on some value, if I get to this point, I've already determined, yeah, this was a valid int value I entered, right? It passed through the next int filter, so I know I'm going to have a valid int value. So anything that happens at this point, I've sized the array correctly and I've given it a valid value. It's just that maybe I've entered in a bad index. Okay, so let's try it. We'll run this and we'll get different messages. Like I said, if I do one exception, I get this. If I do another, I get that. I'll put in the last one as a catch-all. Say unspecified exception type. Okay. So first of all, enter the array size. Let's do -1. Boom. You got the unspecified exception type. Well, that's an interesting thing. I'd like to see what happened there. I'd like to see what the exception is. So print stack trace. Let's try that again. -1. Aha, negative array size exception. There's a special one for that. Okay, so I'm going to do that. I can give it its own catch block. Negative array size exception. And we'll say system.out.print line array size cannot be negative. Okay. So when I run this now, I get that one. Enter array size -1. Great, I've gone to the correct diagnostic message. So let's go through, we'll try to play fair this time. Array index 6, enter valid value 12. Array index to update, let's do 8. Aha, array index out of bounds, right? I said the array 6, so the only valid indexes were 0 through 5. So when I entered in do something to index 8, well, I got this array index out of bounds error as an invalid value for this particular array. Okay. So very quickly, the way this happens, if you have a try block that can throw more than one exception type, you have the option of trying to handle them all with their individual exception types, or you can have one or more umbrella exception types to catch them. For example, if I somehow threw an exception that wasn't any one of these, I could have this kind of exception. E is the parent exception, rather, is the parent class of all these little special exception cases. So anything that doesn't get caught by one of these is definitely going to get caught here. Okay. And this seems like a good place to take a break. Kind of going to call an end to it with the stopping and the sharing and the stopping of the recording.